So we are live, going to StreamYard, and we should be going live on YouTube imminently. And it looks like we are live on YouTube. So there we go. Okay, right. I think, hello, we have people on the stream. That's good. That's good to see. It's good to see it's working. It's good to see the future is, in fact, here. Welcome, everybody. Welcome to Lambda Lounge in our new remote format. I think this is about the third one we've done. So we're still working out the format a little bit. As you can tell, I'm a little bit croaky, so I'm going to briefly just say hello. Welcome to Lambda Lounge. I might be cropping. I'm going to be running the stream this evening, so I might pop up and down to help with comments and whatnot. But tonight we're going to be in the very safe and very organized hands of Hakeem, who's going to be taking us through Unison. And without further ado, I'm going to let him talk about it, because he's the one that's been playing around with it for several weeks, and I don't really have much sensible or intelligent to add to the subject. So Hakeem, take it away.
Thanks a lot, Alex. That was brilliant. Yeah, Alex will pop up again if you can't hear me or anything's really confusing. Also, our co-organizer Connor is sitting on the stream. So if you've got any comments, then please do leave them either on YouTube or in Discord, and as I say, Alex and Connor will pop up and pass on your comments, and it'd be really good to see what kind of things you'd like to do with this new language. So my name is Hakeem. I work at the BBC as a sort of software technology training person. I've been a software developer for many years, and I'm really into various things, including Perl, but don't hold it against me, and also functional programming languages. And been really interested in a language called Unison, which I think has been around for a little while, but has just gone into alpha testing. So it's kind of open to the world to kind of cautiously test it recently. And I don't really have any slides, but if you go to the Unison web site either now or later on, you can see a little bit of information about it. And what they like to do is call it a friendly programming language from the future. And this really intrigued me, because it's a language that's heavily inspired by languages like Haskell, as well as Erlang and various other sort of academic languages, also Scala. But certainly, if you think of Haskell, Haskell is many things. Really like Haskell, big fan. It's not the most famously friendly language in some senses, and the idea of taking that as being one of your core values was really interesting to me. And also this idea that it's a language from the future. And I think that's why they like to focus on emojis, possibly. So I'm not going to do, as I say, a big spiel. I think what we should do is really get in and play with the language and kind of see what happens. I'm hoping to do quite a quick tour of what I found over the last couple of weeks, just playing around with it, doing, a little bit of sample code and so on, and then really see what all of you on the stream are interested in, and what kind of direction you'd like me to go. And then so as I say, do shout out on Discord or YouTube. So Unison has a big idea. It's a simple idea. It's basically content addressable code. And if you've looked at all into how Git, for example, is implemented, you know what a big deal that was in terms of what came before it. Compare that to Subversion and CVS and so on. And what they like to promise is that things like refactoring and renaming are really simple. Your builds and compilation are really simple, and you can push stuff out to distributed systems really easily. I think distributed systems I haven't looked into at all. I think possibly might be a bit beyond capabilities, but maybe not. We can have a look. So getting started with it, if you're interested in either following along or installing it afterwards, if you go to the Unison website and look at the docs, you'll see that it's in alpha at the moment. So they're thinking of it as a private alpha. So they invite you to go onto their Slack and get the instructions from there. The idea being that then if you have any issues, you can ask them for help. And I've been on there for a couple of weeks, and it's pretty nice. So the way we work with it, again, text editor and a code base manager. So I'm going to start off by I'm going to use a code base in here. You don't have to do that. You can do it in your home directory, but I have some code in there already. And I'm going to init this directory like so. And that's generated a new code base. And what that then allows me to do is to open up what looks very much like a nice REPL with some rainbow colors on it. And so it looks like a REPL. And so the first thing, that I did with it was, try to write a couple of commands, and nothing really works because it isn't a REPL. So if we type help, you can see that it has commands for interacting with functions. You can add functions, you can merge things, copy them. It's got some metadata stuff. We'll look through some of these. You've got some nice things like ls and find, which will find functions and terms that are in here. So if we list, there's nothing, and if we find, again, there's absolutely nothing. And the reason is that, and again, all of this is really nicely documented when you first go through it. The first thing you have to do is actually get some code to play with. So if I run that pull command, which pulls off the base libraries off GitHub, you can actually see it downloading all of the definitions, and then it's going to come back with all the new things that it knows how to do, which doesn't take too long, I seem to remember. So yeah, so there you go, and you can see that it gives you a nice paged view of okay, so 1,221 items, and you can see there's things like abilities and built-ins and uniques and various types, and then all these funny hashes, which are the content addressed functions, and yeah, so that's all quite exciting. So I'll come out of there now, and if I run those list commands again, so if I ls, it shows me that there's base, which contains 100 and all those definitions. And in fact, if I list what's in base, I again get to see those. And you can almost think of it as a directory tree, so you can cd into base, which I think is quite cute. Or you can use namespace instead, so you can namespace and cd basically synonyms of each other. And you can also find, which does kind of the same thing, but you can find, for example, the plus symbol, and you can see that there's a couple of options. There's a natural numbers one, which you tend to end up using, and you've also got plus plus, which looks like it's going to be doing list concatenation and so on. So now, okay, we might think, oh, now that we've got some functions actually in the REPL, can we now, kind of add, now that we have a plus there? And again, it doesn't know how to execute anything. And what you actually do is, well, first of all, I'm going to create a namespace for Lambda Lounge, which is currently empty. So if I ls there, there's nothing in it. So back on my Scratch file, I'm going to run some code. And so this is a text file. It's called scratch.u. And Unison looks for any file that you have recently saved, which ends .u in the current subtree. So the moment that I save that, you'll see that on the right-hand side, it's given me a new definition, which is this greet command, which takes a value of type S and it returns a value of type S. It doesn't know anything about it. And if I type greet Lambda Lounge, it's returning Lambda Lounge. So there we go. In fact, what I want to do now is let me just take that nice emoji, and what we could do is one of the typical kind of hello world functions. And if we write like hello and plus plus s, and then add that nice emoji there, then when we run that, you'll see that we get this nice greeting in the codebase manager. So, okay. Yeah. So why is that running in there? And the reason it's running is because of this expression here with a greater than sign. And what we can do is basically add any code that we'd like to run. So here we can do this kind of REPL stuff that we wanted. So here I can add these two numbers. So there we go, 246, and we can see what kind of data types you've got, and they're very much like Haskell ones. And oh, let me just there. Okay. Oh, apparently there's been a comment about Smalltalk. So yeah, comparison with Smalltalk. So yeah, so Smalltalk is another one of the languages that has influenced Unison. And so this idea of a code base manager, which has all the definitions in there, is based on that idea of an image. Here we go. So Lee Hambley, Hakim, have you ever played with Smalltalk? Sounds similar. Yeah, so I think it's like that. I've never played with Smalltalk myself. Recently, I was playing around with Forth, and bizarrely, Forth is a really weird sort of interesting, quite kind of almost low-level, high-level language, and it has a lot of those ideas as well. So it's a really ancient idea that currently doesn't seem to be all that popular, because we're very much into kind of writing stuff in text editors. So you've got these watch expressions that you can run, and you can create these functions. And now that I've created the function, remember it said that the definition is okay to add, and that's hinting that I might want to write add in the codebase manager. And now that I have, it's added the definition. Remember before it was a S to S function; it didn't know what type of variable I was using, what type of data I was using. Now, because we've got a string Lambda Lounge, we're returning that string. It knows that it must take a string and return a string. So it's got all that good kind of Haskell ML type inferencing stuff going on, which is really nice. So that's been added. Obviously, if we want to, oh, my cat says hello. He's a big fan of functional programming. So if we change the definition and we save that again, you can see that the watch expression here changes, and also we get a note that the name already exists. So if I would type add, well, there's nothing left to add, but I can update the current definition. So if I update that, that is now in the code base. And so I say it's in the code base, and I'm so confident it's in the code base that I'm just going to go wild and delete it from my text file. And as you can see on the right-hand side, even though I've deleted it from the text file, running that watch expression, so greet Lambda Lounge, still gives me the same thing. And I can do nice things like well, first of all, if I ls now within there, I can see that I've got a function. And I've got a patch. Oh, and I don't know what the patch is, so that would be interesting. Oh, lovely. So Connor has mentioned that Runar Bjarnason is on the stream. Hi, Runar. So if anybody has any really difficult questions about Unison, we may be able to bring him in later to answer. Runar is one of the core developers of Unison. Thank you for joining. So I was then going to, in the Codebase Manager, view that first definition. I'm going to view one, and you can see that it gives me the type signature, text to text, and it gives me the function. But I never wrote it like that. I didn't write use text plus plus. So it's kind of it's inferred that, and it's actually returning an idealized version of the source code back to me. So, for example, I can now edit that. And if I go back to here and refresh there, you can see it comes back into my editor, and I could edit that. Like, for example, if I put parentheses around things that are useless, if I save that, it doesn't even offer to update it, because that maps to exactly the same thing. So if I try to update, there's literally nothing has changed. If I like, let me just add another exclamation mark there, and then I'll update that. And if I view that greet again, you can see that it's not even bothering with those parentheses that I put in, because they were just disambiguating for me, and it's giving a kind of standard representation back to me. Another thing you can see here is we've got this comment line, and the UCM ignores everything below that fold. So obviously, if I change that now, it doesn't find anything. It doesn't even find these watch expressions at all. So yeah. So I'm gonna carry on, and I've got a few more kind of fairly simple sort of yeah. So Alex is asking, is UCM Unison Code Manager? And yeah, I believe that's what it is. If I help, does that actually Unison? Yeah. Anyway, yes, it is. As far as I'm aware, it's the Unison Code Manager. And so the idea is it's kind of it contains all the source code, but not just the source code. So if we look at this here, we can see that it had a patch, and I don't know what that's going to look like. If I try view 2, okay. So I haven't really looked into the patch management. Essentially, I think the patch is like a diff or a commit in a version control program like Git. You can do things like a ref log, which will show you all of the changes that have been made. So I pulled all of that code, then I added a new function, and then here we go. So it's actually generated this patch automatically a couple of times when I've made these changes. So I'm assuming that trying to view the patch should do something useful. Obviously, this is in alpha, so we're going to get a few little interesting things along the way, I think. So the other thing I wanted to mention actually is that if you look for let's say map, for example, and you can see that there's a couple of things which are like docs and tests. So if we looked for, let's look at this non-empty. So if we find non-empty, we get a whole load of things. We get the type, and we get the function. So if I view 1, we get that's how the type's declared. It looks very much like a Haskell type definition, though it's declared with a type keyword rather than a data keyword. And the 2, I think, is the same thing, but is the definition. And then we've got some of the operations on it, like concatenation. But if we look at append, so let's find that, and you can see that it's got a document and a couple of tests. So if I view that document, you can see that it's got this sort of nice documentation string format, and these are actually links. Let me see if I can find out how to. You can see what links to a term. So if I link that, it is linked to Runar, who's the author of it, and Unison computing. I think it's going to be, maybe it's possibly linked to, if I find append, list non-empty append, maybe it's the ++ list.++. So if I run links on that, I'm trying to, damn it. Let me see if I can find another. If I do find again, find dots in the main thing, I'm going to look for these docs and I'm going to find Boolean and. There we go. So find and. So links Boolean.and. Docs Boolean.and. Oh, that's interesting. So I'm sure we'll come across something there. Obviously, a lot of these don't yet have, and then no docs use. Okay, so yeah. Yeah. I'm going to move on, and we'll come back to this. It is really nice. So once we come across something like that, we'll do something cool with it. So let's get on to tests, because tests are actually really nice. So you can see this expression here looks okay. I need the full name. It says Runar. So docs. So it'll be doc base dot and then okay, anyway, never mind. I'll try one more time. Base dot boolean dot and. There we go. So we have we have the documentation for and you can see that it's now nicely formatted. It's got the this is the actual current name of that, which is really nice. We'll play around with that in a bit, because I just want to try running this test. So we saw that we had like greater than sign to just run some code. If you do a test thing there, it will create a new test expression, and I think this might work. Here we go. So that's failed because basically because I need to edit the greet expression and make it pass. So hello Lambda Lounge plus a single exclamation mark and then a wavy hand. So if I run that now, oh, I need to run, then that test has now passed. So essentially, it also has created a new definition that I can add. So if I add that test, I need to update the greet expression first, and then I run the test. Now, if I run tests in here, it'll run all the tests that are that exist within Lambda Lounge. And it also has cached that test result. And the reason being that once it's run it once, it's a pure function, so it doesn't need to run it again. It just keeps the result and goes, well, this is going to pass. If I change the definition of this, so if I save here again, you'll see that again it's cached. But if I change the definition, then it's not cached, and obviously it's failed. Oh yeah, it's run with that exact same version of the code before. So if I put a completely new version of the code, then it'll fail, and it's not cached this time. So that's really interesting. So it caches every version of the test that you've run with every input for it. That's kind of mad, isn't it? So let's put that back to there, and we've got our passing test. And we can also add the test.x1 into the code base. Now, when we list, we can see that we've got greet, and we've also got greet.tests.x1. So which is a function that returns some test results. which I think is quite nice. If we go back to the base thing and we run tests, that's now going to run a whole load of tests, and I mean they're quite fast. Okay, 166 tests. Obviously, if you think they were about 2,000 terms, you can imagine that there's going to be a whole load more tests at some point, which would be nice. But if I run that again, then of course those are all going to be cached. Where's it say it's cached? Here we go, cache test results. And again, it's got some nice friendly comments about the test cache, like so. Cool. So yeah. Okay. So someone mentioned that it would be nice to have a Lisp that had this kind of immutable definitions. And I think an old Perl monger I used to know called Zephram was working on a Lisp that was content addressable. And Arya, who's one of the other core developers of Unison, is also on the stream. Hi, Arya, and has popped up to say that they are considering an S expression syntax for Unison as well. That's quite exciting. So I wanted to show you this, which is part of the still part of testing. It's the code. It's the property-based testing stuff. So if we look, there's a couple of functions. I copied this definition, so I don't really know what I'm doing here either. So we're going to explore this together. So if we look for that function there, view nat in, let's see if it has any docs. No. Oh no, because I need to fully qualify the docs, don't I? Which I think isn't obvious. Okay, anyway, there's no docs for that. But essentially what that's doing is it's taking a pair of numbers. So you can see I've got 0 and 10, and it's returning a generated number. So presumably it'll be a random or kind of iterated number. And this sample here is going to take a sample of, well, I would have thought it was going to be 100, but it's only shown 10. I don't know if that's because it's truncated or look at sample, and I need to find sample and then view the second one, or is it, yeah, 2. That's an ability. I think it's probably this one that I'm looking for. So let me view 4, and so I think it's using weighting to decide which numbers it's going to use, something like that, and it's going to return, in any case, a list of samples. So if we run that code again, you can see that it gave me some things here. And Connor's suggesting it'd be a good idea to look at abilities, and I think we will do. We'll have a look at those in a bit, because I don't understand Gen well enough to explain it, whereas I have looked at stream and abort. So we'll play with those in a bit. In the meantime, this stuff in curly braces is what's called an ability in Unison, and it's a little bit like a monad in Haskell. And again, Haskell not necessarily famously the most easy to use language. Monad's not the most famously easy to explain concept. And when I was playing with abilities, at least with the abort and stream ability, I was really thinking, wow, this is like monads, but where's the pain? So hopefully it'll be nice and easy. Basically, it gives you this sort of capability of being able to do something that isn't in the core language. So if we go to here, we can now create a new test that is going to expect, I obviously played with this, is going to expect that expect that every number between 0 and 10, which is between 0 and 10 exclusive on the upper bound is going to be less than 10. So if I run that, you can see that it's run 100 tests, and it's tried as hard as possible to find a sample out of this range of 0 to 9 that is going to be bigger than is going to be 10 or greater. So obviously, if we change that upper bound to 11, then that is going to fail, like so. So that's a nice sort of property-based test. I'm not very good with property-based testing myself. So what I'm going to do is I'm going to paste that at the end, and we could maybe come back to that. If anybody in the audience is really into property-based testing, we could have a play with that a bit later. So what I thought would be nice would be to show how output works. So if we look for, if we find all the functions again, you can see that there are functions with this ability. Again, this is in curly braces of I/O, and you know, if you've done some Haskell, or if you've heard people talking about doing I/O in Haskell, that it all has to be done monadically, and people either go, it's easy, what's the worry, or people get a bit nervous about it. Essentially, it's a similar kind of concept, and it's reasonably easy, and again, it's very well described in the documentation. You have to kind of read it quite carefully, or it won't make sense, but it is actually quite well described. So I'm going to look here for print, and you can see there's a function there, print line, and I'm going to try a few things. They're not going to work because I tried this before. So if I print, we'll come back to that later. So if I print hello, then okay, oh yes, sorry, I need to. There we go. So if I try and just run an IO command, it gives me an error because it says that the expression in red, which in this case is hello, that's not quite right. I think it's actually print line, needs the base IO ability, and this location does not have access to any abilities. So if you look in the help, there is a function called run, and that runs a command. And you could imagine that running a command would give it IO, and in fact this is how you do it. So if we define a function, so we'll call it greet exclamation mark, and we can try this. We go, okay, let's run a function with println IO, and again it's going to complain to me that it needs the ability to do IO, and I never told it that it could. So the way that you tend to do a lot of stuff with abilities seems to be to defer them and then run them in a handler. And the deferring syntax is to put a single quote at the beginning of it. So I think if I run that, there we go, and you can see that that's actually compiled, okay, and it's giving us a type of, there's no input and there's no output either, but we're going to do some IO along the way. That's kind of how you can read that. So from nothing to nothing, but doing a bit of IO kind of along the way. So you might think again, let's try running greet there, and oh, that's very exciting. So that looks like code, doesn't it? So that's giving me some code with some hashes, and it's telling me that it's handling standard out. If there's an error, it'll throw some error, and if it's successful, it'll put the text like so. So obviously that's no use to us at all, but it's really interesting to see how it's implemented, but it's not any particular use. So if I now go with this run command and go run greet exclamation mark, that will actually run the command as IO in UCM. So that's how you do it. And what I thought might be interesting is if we actually made the greet do a print line of greeting Lambda Lounge, like so. And if we run that, then okay, sorry, I need to remove that there. If we try running this, I think that will actually work. Run greet. Yeah, hello Lambda Lounge, and we've got the nice Unicode in there. And I think what it looks like from here is I wanted to give it a parameter. So if we said greet s, so we can parameterize it. So now we have a new greet function, and it goes from text, i.e. this S, which is going to be Lambda Lounge, to IO, and we can add that. And of course, now if we try and run it, it won't work because run has to have no input. So what we're going to do is we're going to create a main function here that will actually call greet with well, in fact, let's say hello to our guests, Runa and Aria. Apologies for the lack of accents. I don't remember how you do them in Vim. I've been using VS Code recently. So now if I run main, oh no, I need to add the main before it's able to be run. So run main. Ooh. Okay. So again, I might be getting slightly lost. There we go. I think that update run main. There we go. So the greet function itself didn't need to be deferred because this function here is actually doing the IO stuff. That has to be deferred. This kind of stuff I don't understand fully. I suspect a lot of it while you're getting to grips with it is going to be, you know, just sort of adding apostrophes and deleting them until it compiles. I'm sure there's a better way of doing it than that. That's my terrible hacky. Let's hope for the best behavior coming to the fore again. But there you go. That's the first ability we're going to look at. And this one's quite an unusual one in that it has special handling in the main program. And the reason for that is obvious. It's, well, the embedded program has to have some bindings to let you speak to the outside world. So okay, so I thought I would try doing some work with some data types, just because that's always fun. So if we look for things that are types, can we do find type? Or we can do find and then search for types. We can see there's booleans, there's bytes, char, docs and either, and so on. So, a couple of things, because this confused me, is that is a character. So that's actually, I wonder whether I can I add those together? No. Let's have a look. Oh, another thing that's really nice, because of this being a Smalltalk-like image, is that you can search for things that have particular type signature. So I could maybe go, well, if I've got a char and I've got another char and I want to turn them into a string, which I think is called text, can I find anything? And okay, that hasn't found anything. Let's find a char to, let's find a list of chars to text. And there we go. That gives us a from char list. So we could do here from char list, and again we can do. I think this is quite like chars in Clojure, isn't it? There's something, I think, is that with a slash rather than a question mark. So there we go. Yeah. So that's quite good fun. And if we want to create a new data type, again, you can do that with a type. Well, let's try. This is going to be interesting. So if we had a, you know, the classic maybe type, it's either a just or it's a nothing. And if we save that, here we go. So apparently a random Twitch bot is spamming our event. So that's exciting. Apologies, I'm not seeing that on my view, but apologies if that's causing any problems. So you can see here that it's found this type, maybe A. Okay. It recognizes that it's the same thing as base.optional. So if we look at optional and we view that type, in fact, let's edit that type. You can see that optional A is none or some A, and oh wow! So this has found that even though I've named it maybe rather than optional, and I've got just A instead of some A and nothing instead of none. I've even put them in a different order than that has, which is really interesting. But it's recognised that they're basically the same type, which is really interesting. So I wonder whether I could put if I put that X, which is an optional nat, and say that X is nothing. Will that work? Sorry, I need to unexpected equals. So I think I need to let there are no constraints on its type. Okay. Okay. Not quite sure what I'm doing here, but the interesting point is that to Unison, these two types are actually the same type, and you can pass a value of one of these types to something else, which is kind of interesting. And if you don't want that, which you might not, you can look for unique types, and unique types then prevent you from being able to do that. So if you had like an enum of 4 different things and you don't want it to be confused with another enum of 4 different things, then you'll want to set it as unique. So yeah, so as you can see, some of these kind of syntax stuff, I've just been playing with stuff, and you kind of it works pretty well, but it's always hard to do when you're live coding. So again, if anybody has any suggestions of something they'd like me to implement, then please go ahead. Otherwise, I'll carry on and move to refactoring. This is really interesting. So if we look at what we've already got, we've got our greet function, we've got our make a greeting function and the main function. So if we can check how that works, you can see that we've got the definition of that. If I want to rename that to something else, so rename term greet to salute. Oh, it's not a term. Is it a term? Because I'm not in Lambda Lounge. So greet to salute. And now when I look there, you can see that so salute is there. There's still a greet directory, which is interesting. But if I run that, it doesn't know what greet is anymore because we've renamed it. So I'd have to there write salute. Okay, and salute Lambda Lounge. Oh, this is also really nice, is that you keep on seeing there, I just typed literally the definition of that, and it showed me the source code for it. So I didn't even need to type view because each function is serializable, which is really nice. If you think if you try and view a function in Haskell, you get, this does not have a show instance. All of these are actually still code, which is really cool. So if I salute hello mum, then there we go. So you might think, well, what's happened to greet exclamation mark? Is that still going to work? So if we run main, for example, I must have done. I probably never added. Or did I do? Was main in base? No. Okay. I'll sort that out again in a bit. But yeah. Okay. So Alex has passed on a question about how do you actually store a program and run it? Yeah. So yes. So if you look in the help, there is a set of what's it called? So you have these patches that I haven't really looked into this very much because I, as you can see, I'm nowhere near the point of getting any kind of releasable code. But it might be a good idea to actually have a really quick look at what the code base looks like. So this is let me come out of there. So I'm now in my shell, and if I look here, there's my Scratch files and some other things I was working on, and you can see in there's a .unison file, and Unison v1. You can see it's got patches and terms and the ref log and so on. So if we look in terms, you can see it's got a whole load of weird stuff there. So let's just look at one of those at random. No, maybe not. 6, 7, 8. Okay. VV. Here we go. VV0. Okay. So in there we've got a type.ub. Let's look at that, and that's got some weird compiled stuff, and the compiled UB is also some compiled stuff. So basically, under that hash, so it's a VVOC. We'll find out what that is now, so the nice thing here is that each of those are kind of append only. So you can actually, I haven't done, but if I were to get in it here, I believe a lot of people will just literally put their whole code base up on GitHub. And remember when we did code base dot, so when we did the initial pull, you can actually, if you go and look at github.com Unison Web Base, you will find a code base exactly like that with the .unison and so on, and all of the definitions in there. And the act of pulling that, that's one way that you can distribute code. And the other way is with these patches, which I'm not going to go into because I don't understand that. But so essentially, yes, you can actually store and ship code quite nicely, and they have some really interesting ideas about how you would transfer code from kind of a central machine to a remote machine, and you might kind of go, here, try running this hash, and it'll decode the hash and go, well, I need to run this piece of code, and ask the original place for that, and kind of, it's more optimized than that. But essentially the story is that like with Git, all the things that you refer to, and you can pull them across kind of as needed. So what I wanted to do was to find out, it was VVB, wasn't it? Here we go. So if so that hash that we looked at above maps to a generator for hexadecimal digits, and so essentially that version of that code is under that hash. So if we look at if we look at, let's cd back into Lambda Lounge, and we look at salute, I think I can tell, is it names salute, and you can see that it has this this hash here, ro6hr7ekjs. So now if I edit salute, salute. Hang on. Again. Okay, so if I edit that and I go Aave like so, you can see that I can update that. And when I update it, if I do names salute, then it's now got a new hash. And I think, I'm not sure, can I do that? Here we go. So yeah, so you can actually call one of these hashes as if it was a function. So you can see that salute is currently the same as if it was TB, etc. So if I run that, I get Aave mum, Aave mater, and then, but I can actually call the previous name of it. So and call that salute like so. I wonder if can I call that any name? Hello. Okay. So it remembers that this thing has been called salute with that hash, even though salute currently is mapped to saying Aave mum. I can tell it that salute with this hash will still point to that function hello mum. So even though I've changed the definition of the function, we've still got access to it in the code base. And I think there's also a history command, which I don't entirely understand how to read all of that. I wonder, can I do history of salute? No, because it's a history of a namespace. So this is a history of Lambda Lounge specifically. So it's telling me that, okay, the greet tests were added, the salute was added and updated, we've moved greet to salute, and so on. And so you can now look at any definition at any point, which is really nice. And I think there is, like, possibly, like, you know, if you've used live passwords in there, for example, you might not want that just sitting in your kind of code base history. So I think when you actually come to publishing something, you know, to production or to, you know, somewhere public, then you may want more control over that. And I think that's probably a story that they're working on at the moment. So we also wanted to look at the things that, so there's a dependence of greet. No, help. Dependencies. No, it's called salute now, isn't it? So salute depends on text, and it depends on the plus operation. And if we look at dependence of salute, you can see that that's interesting. So the greet.tests.x1 depends on it. So if I view that, you can see that now we never typed this in, did we? We typed in greet Lambda Lounge. So if I run that test, okay, it's failing because of course I've changed that to Aave, so I'd have to do that, update and test, and that test now passes again. Yeah, greet.test.x1. So view greet.test.x1. And right, because the definition is based on the hashed functions. Even though I've changed the name, the definition is the same. So you can see that we ran this test ages ago when the function was called greet, And even now it's called salute, it hasn't bothered to rerun it. It's just it just magically go, well, yeah, it's called salute now. I've already got it cached, which is quite cool. So in fact, if I do name salute, you can see that it's gone back to this RO6HR because we changed it back from Aave to hello. And this kind of stuff is sort of slightly mind bending to me, but quite cool. So, and I think there's a question coming in. I'll just okay. So I'll carry on, and for now, please do keep on asking questions. I can see Alex and Connor kind of passing those over to me. So let me move on. Sorry, no, I wanted to have a function that depends on that. So we've already seen, okay, we've seen that this test function depended on it and it just got magically renamed. But you might say, what happens if we suddenly totally change the kind of function and it can't automatically do that? So let's write a let's write another function, which is a gladiator salute, which we call it gladiator. And again, that takes an S, and it will return salute of S plus a new line, and those who are about to write Unison salute you. Okay, someone in chat suggested that renaming is affected by linking. Okay, so is that linking? Okay, if linking them would fix that. Okay, yeah. So we pointed out that the test has a particular name, and that name is greet.tests.ex. I think we'd have to rename. Yes, so the suggestion was that if they were linked together with metadata, then that might have automatically renamed, which is definitely worth looking into. Let me put that in the list of ideas. Linking tests to function does that affect renaming? So we can definitely look at that. So I'm going to run this gladiator function, and so I'm going to gladiator Caesar, and now we have hello Caesar, those who are about to write Unison salute you. Okay, so let's add that. And so what we might do now is, I think, yeah, okay. So Runa has clarified that, yeah, linking, you do have to move the whole thing, and I think that's fine. You know, kind of we've moved one definition. Maybe it would be nice if kind of cascading link definitions do move, and you know, who knows. So what we're going to do now is we're going to go wild, and we're going to parameterize salute to take the greeting and the person you're greeting. So we're going to have the greeting, and let's do greeting and person, like so. So now, and this one there is going to take Aave, because that's how gladiators speak. Oh, hang on, no. Let me just delete that first of all. So the idea is we've changed the salute function now. Okay, so I'm going to save that, and it's noticed that salute, which used to be text to text, is now text to text to text. So it has two parameters and returns a thing. So I can update that, and of course now if I try running gladiator Caesar, then that's not going to work, right? So you might think, okay, well we've renamed that. You know, what's going on? Why didn't it sort of change the definition like it did with the tests before? So if we view the definition of gladiator, again you can see that it's actually put in that hash there, and it's specialized it to the old version of salute. So if we want to edit that, if we look at our to-do list, we can see that it actually tells us we want to update both of these functions. So let's do that. We edit 1 to 2, I think we can do. Yay. So reload that. So, oh yes, of course. Yes, we need to update both of these. So we're going to say Gladiator is going to, we'll put it back to the current name rather than the hash name, and we're going to say Aave, like so. Let's just check that that works. Text to text, and now if we go Gladiator Caesar, that's going to work. Oh, Aave says that's not quite right, is it? It's fine. It's close enough. We can edit salute again in a bit, and now get rid of that, and let's change this this greeting, and we want to again put like that, and we want to put hello, and update and test. And of course it's failing because of that same thing that we discovered with the that we're missing a space. So basically what I need to do is add a space there. Okay, let's get that and run the test, and that now works. And this is a new test result because it's using a totally new version of the function that it didn't have before. So while we're here, we may as well move. It's a namespace, isn't it? Greet to salute. Okay, so now when we run the test, it's salute.tests.ex1 rather than greet.tests.ex1. So again, yeah, not everything is done automatically, but a lot of things are, and you can be quite confident that having done that, if I run the to-do list, I still have Gladiator. That. Oh, maybe I didn't. I probably just didn't update that. So update, and now there's no to do. Okay, so that's all done. So essentially, we've seen that you can rename functions, and all of the linked functions to them will try and automatically update if they can. If you change the types and they can't, then they'll just carry on pointing to the old function, but you get a nice to-do list. Now, I think you should get like a red mark, you know, like in well, like in my nice Powerline shell here, where I get all the weird little sort of pop-ups telling me that that I'm in a Git repo or whatever. It'd be really nice if it told you how many to-do items you've got left to do. So maybe maybe that's the next thing to add. So yeah, that's that. Whoa, how is everyone doing? So we've been going for about an hour. So what I thought, I'm really happy to kind of either wrap it up if people are exhausted, or I don't know whether anyone would like to suggest a particular thing that they'd like me to explore. I'm happy to carry on for a bit longer. Cool. So let me just kind of quickly go through the other things that I had lined up, just to kind of give you a bit of a flavour, and then I'm happy to take some questions, and possibly if Runa and Arya are still there, then they could either answer the questions, or I don't know if Alex wants to invite one of them on if they would like. So maybe types, really interesting. That also interacts with abilities and handlers, and that's really cool. Good stuff to explore. You've got the libraries, where again you can pull stuff down into your code base, which is really nice. And then, yeah, a couple of other ideas were, what we could play with. Like, I've been working on some XML handling stuff. Be good to look at record syntax. Algebraic effects are really cool. Just the idea of being able to test really complex IO based stuff in a really pure way would be cool. Okay, so yeah, so Alex pointed out, if people are interested, do let us know, and we can maybe organize another sort of longer Unison session, and possibly it's an open invitation to run an area. If you'd like to come along to a Lambda Lounge session in the future, we'd really appreciate it. So does anyone have any questions or requests? So I don't know, Alex, if you want to come on, or put Connor on as well. Just to fill in a bit of the quiet. Okay, so Dara's asking about the effect system. So I think so I don't know whether that's meaning and another question as well. Okay, so I think that's going to be more about the IO stuff. Okay, and Lee is asking, how could we apply this to the day job? Regular web appy stuff where we die in continuous integration and testing tar pits. And that's a really interesting one. So if you look on Unison Web, there is a directory of talks somewhere. I think it might be from the tour of Unison. Anyway, in there's a link to a number of talks which have mostly been done by Runar and by the other core developer, Paul Cusano, and those really go through a lot of the really cool stuff that Unison's capable of, and talk about their vision for using it in distributed computing. So the other really cool project is there's a Unison RS for Rust. Let me see if I can find the URL for that. Okay, anyway, there is a port of Unison, or sort of an interpretive Unison written in Rust, which will compile to WebAssembly. So the idea being that you could have Unison code running in the browser, which is then potentially talking to other Unison servers on distributed nodes. So I think obviously, you've got to be a little bit cautious because this is alpha. And so, would you be using alpha code in production? You've got to decide how brave you are. I think the ideas in it are really cool, and I think those will be definitely very likely in production. So I think I was going to wait and see if there's any more questions. Okay, and the question about effects. So we had a really quick look at yeah, so they're asked about effects. So I suppose maybe then it might be worth just having a quick look at this this maybe example, which is obviously a very simple kind of the simplest monad pretty much, but it is really nice. So if we had a type of things, as we all know, can be either foo or bar. And if we've got a function, I'm going to go for really bad names unless somebody shouts me out a good name on the chat. If we frognicate a thing, then in the case that it's a foo, then we're going to return this is a foo. This is what happens when you frognicate something. You get a string back. Okay. And of course, because I'm under the fold. So, okay, there is no data constructor called foo. The type thing is foo or bar. I need to add that first of all. Okay, so let's add type thing. Okay, now we can just that. And oh, sorry. Cases. Ooh. Okay. Let's do frobnicate. Frobnicate is cases. Okay. See, I should probably look at some syntax. So why don't we look at something in the main code base that might do some kind of pattern matching, and then we can just look at what that might look like. So let's think what's ooh, heaps and things. Okay, children. Let's try looking for heap children or union. Okay, so let's find 13. View 1. Okay, match. Okay, let's do match because I think I know how to do that better. So if we frobnicate a thing and we match a thing with if it's a foo, then okay, this is a foo. Do I need to type thing.foo? No, maybe I need to use thing. Okay, add that thing. Okay. Yeah, so I'm making the point that this code needs more cases, but that's actually deliberate. The first thing I'm trying to do is just match on the one thing which I thought worked. Okay, let's try then. Bar this is a bar because okay. No, so yeah, so the interesting thing was that I tried it before and found that it didn't actually do exhaustive pattern matching, and so which was really nice if you're just kind of just hack. Okay, let's do because we know that optional works. We have optional. So if an optional is none or some. So if we find some one, then we're going to do that. Okay, here we go. So we now have a thing called frobnicate. So if we try to frobnicate with some one, we get this as a foo. And that's great. But as somebody rightly pointed out in chat, I never actually wrote the other case. So I think they have a plan to make it do exhaustive pattern matching. I actually quite like that it doesn't do that, just because it sort of it let me discover this behavior here. So now, of course, there's a pattern match failure, and this happens when calling a function that doesn't handle all possible inputs. So that's definitely a problem. But we want to just return a string. And if I now have to go, okay, now I've got to return a sum, and I've got to modify it. It's a bit of a pain, isn't it, when you're refactoring? So what would be really nice is if you could just go, I don't care about changing the type signature of this at all. I'm just gonna do that, and that works. So you can see here that I'm handling it, but I'm returning something of a completely different type. I'm not returning a string anymore. I'm aborting. You might think, well, is this type safe? So if you look at the definition it wants to add, it's getting an optional natural number, and it's returning some text, but it's returning it with the abort ability. So I'm gonna add that, and so now if I try to frobnicate sum1, then it gives me the same error that we saw earlier with IO, saying the expression in red needs these abilities, abort, and it doesn't actually have access to that. So so if we look at the base and we look for abort, you can see that there is something called a handler called toOptional, and in fact, if we look at the number 69, nice, view 69, then that actually calls this toOptional handler, and it'll handle an expression that we're going to use with this handler, and it'll return an optional. So basically, all we need to do is to write this toOptional. And okay, this won't work either, because it's, if you might remember when I mentioned, thanks Connor, you might remember when I mentioned IO, that you end up having to put a lot of things in these defer wrappers. So if I run that now, you can see that even though this frobnicate is returning either a string or an abort, the handler is making it return a sum. So this is returning sum, this is a foo. And if I now run with frobnicate, let's say sum2, for example, that won't work. So actually what we could do is just, let's just change that there. There we go. So anything other than sum1 will now return none. So to do that there. Okay, so essentially what we're doing is we've got a function that will return some abort thing, and then we're leaving it totally up to the caller as to how they want to interpret that. It's a bit like almost passing in a vtable of here's a load of functions you want to use, or like mocking a whole load of functions, but somehow it feels kind of a lot cleaner, that you can kind of decide that I'm going to emit a list of algebraic options, and then you can handle all of those. So you might have some code that you only want to be able to call a web request or something else, and then the handler will just do those two things, and there's no way that that code can do anything other than just handle those things. So for example, what we could do is, I showed you that handler. So look, find to optional. So if I edit that optional handler there, and actually might as well edit one as well, then what we could do is create our own handler. So we could go something like did it work, and so we're going to take a value and we're going to handle it with did it work.handler, and then this sort of, this is way over my comfort level here, and it's really worth having a look at the abilities documentation. There's two docs on the doc site. There's a sort of intro, and then there's a kind of language reference. But essentially what you do is you kind of pattern match on it. And what we might do is we could just go, well, if it aborted, we could go, it crashed and burned. And if it didn't abort, then glorious success. Okay, so what's the betting this is actually going to work? So if we now go handle, well, let's handle one of these. So handle that with Oh yeah, no, here we go. So which one did it work? Don't we? Glorious success. So you can see that we're calling exactly the same code as we did before, but because we've changed the handler. Okay, I'm not sure why. Maybe because I didn't update the definition of that. There we go. So instead of returning a sum value like ToOptional did, it's returning a string. So if you look at the type of did it work, it returns a text rather than an optional. So we can totally change the way that that abort is handled, and the other handlers. I'll just kind of. I think this is the last thing, unless there's any more questions from that Connor and Alex passed me. Is I'm going to look again for the abilities, and you can see that you've got that abort, you've got ask, which is the reader monad essentially. You've got exception, which is like either, and again turns that into an exception or a value. Okay, one more question as well. We've got store, which is like the state monad. You've got stream, which is like a kind of collector type thing. It's a writer monad essentially. You've got the IO, you've got this generator, which is used for property-based testing, and you can create your own abilities as well, actually, really easily. So one question, can you run Unison programs from the CLI? So we already did from the UCM that you can do run, I obviously didn't save the definition of it. I think you'll get used to it and stop making that kind of mistake in kind of when you're using it more regularly. I don't know if you can run it from the command line. I expect there will be a compiler at some point if there isn't already. So remembering that this is alpha, I don't think that kind of running code is yet I don't know how much of a priority that is. I think a lot of the stuff is already there, so it probably is the next thing. Cool. So thank you very much for watching me wibble and write code in a programming language I barely know. It's been fun for me, anyway. I don't know if anyone has any final thoughts before we head off. Okay, so while Alex is typing, hopefully some more thoughts. If anybody would like any more of these explorations of code, do get in touch, because we're really happy to take talks. If anybody has a talk they'd like to propose, if anyone wants to do a live coding like this, could be a new and exciting upcoming programming language like Unison, or it could be diving into Elixir, or someone wants to play with Forth, or we usually look at functional languages, but we're really happy to do anything that's kind of a bit, PLT, programming language theory, esoteric languages, or anything that's just cool and of interest to people who are interested in functional languages. So do get in touch with us on Twitter, Slack, or comments on YouTube, and see you all soon. Oh yes, and we have a Discord channel, sorry, rather than a Slack channel, which is I think is linked from YouTube, hopefully, and if not, somebody could put it in the chat, and if not, it is on our page lambdalounge.org.uk, and also on the Skiddle page if you got tickets through Skiddle. So do come and chat on Discord. We'll be there for a little while now. Bye.